Well, welcome everybody. Hopefully, we are live for everybody not here, as well as live for you guys. So thanks for coming. My name is Sam Snow. I do have a brother named Jon Snow, so I am related to the Game of Thrones guy. He does know nothing. I like to say that because he's my younger brother. I'm going to try to stay in focus for the camera. If you log into twitch.com/snowslab, you should be seeing this live feed. Got my little face here. Just for your sake, I'll move this, see if I can show you what it looks like on my screen. My little broadcast platform here. So now you see me a bunch of times and it gets confusing. And I could even show you, yep, this is also true of me on, if you go to Twitch. So just so you know, if you wanted to access somewhere else, it's starting to get really trippy over here. Sorry about that. Now let's see if I can fix this. So if you ever are feeling sick, ever don't feel like showing up to class, you can, oops, that's not what I wanted to do. Let's try to get that back to where it should be. There we go. All right. So all that to say, if you ever wanted to view this lecture a little bit differently, you are welcome to do so. Uh-oh, where'd he go? Having a few difficulties here for a moment, but it should be good in a moment. All right. Okay, so just wanted to kind of show you what the deal is, what it looks like, and this will give me the opportunity to do this. If you're not, if we have to go all the way online, this is basically what to expect. This is automatically going to record on the Twitch platform, so you can just go back there and rewatch it. I think it saves it for like 15 days, so what I'm going to do is download that and post it to YouTube as well. That'll give you the captions in case anybody needs captions. I could also potentially get the PowerPoint itself to do captions live. I haven't done that today, but if there's any need, I could do that for you. All right, so then hopefully what I'll be able to do is take notes on this handy little pad and kind of make squiggles in addition to the PowerPoint. So that's kind of just an overview of what I expect the class to feel like. It seemed to work okay when we transitioned in the spring. I think it's a little simpler than having you all log into Zoom and all that. Just click a link and watch instead. So hopefully that's beneficial. Just so you can see my face for a moment, I'll take off my mask. Hi. So I know I'm not supposed to do that, but it's nice to actually see face to face, right? So there you go. Let's see, what else? Today I plan to go through the syllabus, just kind of tell you what to expect from the class. Wanted to show you this kind of stuff, show you what it's going to be like, see who all was here. In fact, there's a fair bit of you here, so maybe I'll tell you just a little bit more about myself, and then I'm going to use a website called Kahoot and get a little survey from you guys. Whoever's watching online, they're delayed a few seconds, but they could definitely participate as well. I'm not going to rely on these during class normally, because I know there's people that are going to watch later or may have difficulties watching in person. But what I'm going to do here is post this little quiz. So when I hit play, if you take your a smartphone and go to kahoot.it, enter in this number, then you'll be able to participate in this little activity. So normally what I would do is just do these throughout the semester, have little participation activities, include a little bit of a quiz in there. Instead of doing these normally, I'm going to be doing pretty much weekly quizzes on Moodle. They're going to be primarily participation. They're going to ask ask things not necessarily like a big calculation problem, but what was the engineering challenge that this treatment plant faced in this assigned reading that I gave you and we talked about. Something like that. It's not really the stuff I'll put on tests, but it kind of measures your engagement. You'll get most of the participation credit just for completing it. And so part of the intent for me is to give you some free credit as long as you're participating and doing your best on that. So it'll be 2/3 of it just free credit, and then that last third is how correct you are on the quiz. So hopefully it's not a high stress thing. Give some participation. All right, so just a little bit about me. I've been at LSU for 4 years now. Moved here in 2016. Before that, I was in Michigan for 2 years. I grew up outside of Atlanta, and I went to school in Atlanta. So Michigan was very different. Louisiana's a little closer to home, at least weather-wise in the South. Definitely a different South here than in Georgia, I would say that. But I've been enjoying it here. This past week I just bought a house, so I'm working on moving and stuff. So this week I'm kind of all over the place, happy that the technology's working. Yes.
Are you a Dolphins fan?
I'm actually, and I hate to admit this in front of LSU students, I'm not much of a sports fan.
Okay.
So
Better than a Dolphins fan.
if you want me to be, or if that will make you more or less happy at me, maybe I'll say yes or no. No, I don't really care. Good question. So I went to Georgia Tech, and they have some sports, but they're not super well known or anything. So typical nerd fashion, I'm kind of whatever. All right, so let's see. So that's kind of my history. I grew up with a bunch of siblings, including Jon Snow, and I'm 33, and so my undergraduate degree was in Earth and Atmospheric Science. My PhD was environmental engineering. So as far as engineering goes, I probably have a little less experience with like the practical hands-on, what especially all you civil students think of as engineering. I didn't have to take some of those classes. Got the math, thermodynamics, some things like that. And then in grad school I went on, and so I was pretty much always water quality type focused, and then went even further, disinfection. So the research that I do here is primarily using light activated disinfection or oxidation processes. So we'll talk about some of those as we go. Then when I was in Michigan, I did do a postdoc, but I also worked as a permit writer for the Department of Environmental Quality. So I did a little bit of wastewater stuff there. Water and wastewater are a little bit distinct, but a lot of the same principles apply in both cases. Okay, so let's hear just a little bit about you. So I'm going to go ahead and boot up this quiz. So what's your major? I think there's about 60 students total in this class, so that I'm glad to see there's a lot able to participate today. Okay, that's pretty typical, mostly civil. A few EVEG if you weren't able to, you had a scheduling conflict for the other, some chemical engineers, and a few other, there's one other. All right, very cool. So this question often correlates with another question coming up, but not just yet. So how many years have you been here? So some people might have transferred or whatnot. All right. Very cool. How old are you? if you don't mind me asking. It's okay, I gave you some ranges. All right. It's about normal. Okay, where are you from? Basically asking you the stuff that I told you about me, for the most part. I guess technically I'm three states away, but it doesn't quite feel like that. All right. Very cool. So which topic are you least comfortable with? And I find sometimes this correlates with the major question. Can always kind of tell who's planning to get an A in the class. 5 of you there are pretty confident. Okay, but the interesting thing here is we usually have about the same number of chemistry fears as civil engineers. Does that sound about right? So just so you're aware, we do have to do chemistry, but what I'm going to do is give you a nice overview at the beginning and do my best to teach it to you just as a tool. Okay, how do we solve this problem? How do we know the amount of pH we need? And give you kind of the enough backdrop to speed up or to get to speed with the class to solve the problems we need to solve. For some of the chemical engineering majors and EVEG majors and the like, some of it might be boring, and so part of the first homework I'm going to say is optional. For some of the chemistry stuff, I'll explain when we get there. So I'm going to try to balance that for you, give you enough overview and all that. And speaking of, what does this make you think of?
Is it an actual thing?
I don't know. What do you think? I'll tell you in a moment. Okay, so this is also a typical, a pretty good test to see where you're at. Okay, so this was the structure, and I see a fair bit of you said iron oxide because you recognized Fe is iron, O is oxygen, so that sounds like it would be an iron oxide. But as the question pointed out, well, is that really a molecule? No, it's not. So if you look at the other ones, okay, so part of you said that's not possible, that's silly. A few of you got the pun. Several of you just hate chemistry and didn't like the joke, but it's a Ferris wheel because the iron is in ferrous state. There's ferric and ferrous. I have a shirt that basically has that, and that's actually the reason why I remember that ferrous is 2+ and ferric is 3+. Chemistry puns. There you go. Okay, speaking of puns, how do you like them? So by the way, you can, if you're participating online, there's a chat box. You can talk to me or to each other. I see somebody already commented, now that's comedy. So I'm glad somebody enjoys it there. You're free to be anonymous on the message board if we go fully online, or when we do, I guess we're doing that after Thanksgiving regardless. But if you're ever participating there live in the chat, I reserve all rights to ban or mute whoever is being inappropriate, but feel free to have fun talk with each other, ask me questions. I'm going to do my best to interact. I have a little chat box that I can see here, but I'm not always going to be, if I'm busy lecturing, it might take me a moment to notice it and answer the question. Okay, so yes, whiteboards are remarkable. Not going to be using one for the class. Okay, so 10% of you found it punishing, but I made you endure that pun anyway. Okay, so that's fun. Thank you for humoring me and allowing me to get to know you like that. Okay, so we don't need to really talk more about that. Normally I would kind of show you I can download those results and acquire them and stuff. Okay, we're going to come back to the PowerPoint. All right, so environmental engineering, and more specifically water and wastewater treatment. Really what I would say almost all of environmental engineering is really about is mass transformation or mass transfer. So at the end of the day, there's only a few ways we have to be able to think and compute. And it really deals with, you have some amount of stuff. Let me see if I can get my cursor to the right spot here. Also going to put on my handy drawing glove thing. Okay, so if you can imagine, oops. Come back. If you imagine having skill at PowerPoint. Okay, here we go. If you imagine having some water, or really any media, it could be soil, it could be air. We're really going to keep it to water for this class. You have some water with stuff in it, right? And some stuff outside that, because I can't draw. Actually, it's just a little bit hard looking at the zoomed in screen on my my feed here. But actually, this may help if I do this. Okay. So anyway, when we have stuff in a media, so contamination in water, maybe it's pathogens, maybe it's metal ions that are toxic, something like that. Really what we're going to be doing is sending that through some sort of process here. And by that process, we're going to be able to have, afterwards, clean water and a pile of that stuff separated. That's kind of the transfer thing. And maybe we put it in a nice little bag and throw it away. So the goal here is to be able to separate. A membrane would be a good example. We have stuff and we want to get it out, so we send it through a process that's going to separate it. This could be a transformation process where we kill the bacteria, they still stay there inside the solution, but they're dead, right? So it could be transformation, and then my little illustration doesn't make as much sense the way I've drawn it. But the point being, we're going to send it through a process and get some outcome. So that's the very high level. Pretty much the same would be true for air quality. If not doing this type of thing, then understanding how it happens in a natural system. So what is the fate of carbon, geologically from being sequestered in the ground, being used as a fossil fuel, or consumed from an organism and released atmosphere. That understanding that whole cycle almost always involves, these systems almost always involve that mass transfer, mass transformation. Now transformation, we still have the conservation of mass in all of these cases. Just in the case of, let's say, bacteria, if we're disinfecting it, they're still there, the mass is still there, but we've caused that transformation so it's no longer in a pathogenic state. Okay, for the class, we will talk about water treatment. We're actually going to spend more time on water treatment and then kind of a third on wastewater treatment, primarily because a lot of the principles cover them both. And so when we talk about sedimentation, for example, that's used in both, but we're just going to cover it in the first part where we're talking about water treatment. Water treatment, you can kind of split it up into two categories. We'll talk about this before long. You've got health standards, So your water must be clean enough to not cause any harm to you when you drink it. And then there's some aesthetic standards where we don't want it to be discolored or taste bad or smell bad, even if that's healthy. Like even if you were to test and confirm that this water that's kind of stained brown is fine to drink, like tea. Tea is fine to drink, but we might not want it that way for just aesthetic purposes. People might not, maybe less likely to use it, stuff like that. Wastewater, really what it's going to be about is protecting what we intend to use or might intend to use any of our natural systems for. We'll focus primarily on wastewater discharge to rivers and streams and lakes, to water bodies. The same would be true though if you're discharging to groundwater, that there are permits to discharge to groundwater. When I briefly worked as a permit writer, I was working with discharges to surface waters. So I know a little bit more about that, but kind of the same principles apply. We want to make sure that if it's groundwater, we're still able to use it for drinking. It's not going to contaminate somebody's source, maybe for irrigation wells, for crops, or for watering cattle, something like that. Whatever we might want to use the water for. Typically, we think surface waters, it's recreation, that's fishing, swimming, boating, water supply, the ecological impacts. We like to have thriving ecology. Humans are more important than the animals, but we love animals, so let's protect the animals as a priority, right? So there's a kind of a system of priorities here where, we want to protect our habitats so that we can enjoy that. One case study we'll take a look at is literally rivers catching on fire back in the 60s and 70s. That was a big problem and spurred a lot of our attention to wastewater treatment in the US. Okay, so about kind of returning to the class, the logistics here, we will have 3 exams, that's including the final. So there'll be the final exam after Thanksgiving, obviously. We already have a preliminary date up, so I put that in our syllabus. We'll check again as the time gets closer to make sure it didn't change. We'll have 2 midterms, so it'll be, the first midterm will cover basically all of the drinking water side, and the second one will cover all the, excuse me, I said that backwards, or said that wrong. The midterms will together cover all of the drinking water stuff. The final will be a little bit comprehensive and cover all the biological wastewater treatment kind of stuff. So the way it will kind of work out with the homeworks is the first exam will cover the first 2 homeworks. So the chemistry, mass balance, units type stuff, getting you back on the same page as environmental engineering type of work. And then the second midterm will basically be on filtration and disinfection. Now that you have the tools to work with dilutions and some of the chemistry to do disinfection type of stuff. And again, the final exam will be mostly on the biological treatment, but inherently have some comprehensive aspect to it. So maybe we would say it's 50-50, but by that point you'll see that almost every topic kind of builds on what you've already been working on. Okay, so the textbook here, this is the one I recommend for the class. You'll see it on the syllabus as the required text. I think you can probably do without it if you had to. I'm not going to tell you do problem 13 on page 45. That's not the way I'm going to assign homeworks. I'll probably take homework and exams from this book, from the problems and from the example problems, things like that. So it would be a great resource for you. Almost all of the content that I'm going to teach about is going to be directly from here. So it's a good measure of the scale of information you're going to get, the scale of the problems you'll have to solve. So I do recommend it. I heard before class that maybe the library doesn't have it in stock yet, or there's some issue there. If you need me to contact the bookstore, I'll try to do that. But you should probably be able to order it online if nowhere else. And again, you don't have to have it immediately. In my opinion, might be helpful if you really know you're going to struggle with chemistry. I would encourage you to get it early because there's some good chemistry background there that you could use. Okay, so with that, I think I'm just going to go over to the syllabus. Okay, so this should be what the course looks like to you because I set it to student mode. What I'll do is I'll be posting the lecture files. I have to upload it to YouTube and get a link for you. So it takes probably a few hours, depending on what the rest of my day will look like, before I can actually post these lectures. But I will be doing that, and what I'll do is I'll post them as links here, usually under the sections that we're going to be working with. So today I'll probably just post the lecture link kind of in this introductory section. I have a table here. We'll get to the syllabus in a moment, but I'll show you these first. We have this table, this formulas and tables. This is what you'll see on the exams. So this is what you'll have access to. That'll be kind of on the back page of your exam. You'll have the periodic table, this table of units, and some formulas. So instead of letting you do a formula sheet, something like that, you'll have access to this stuff. I'll expand that with more formulas with exam 2 and the final, so you don't have to worry about that. Okay. I also listed the practice problems. If you open this, I think it's a PDF. Or no, that might be an Excel sheet. It basically takes each topic that we're going to cover and tells you, okay, I went through the book and I said, okay, these problems look like they're related to these sections, and they're from this book, so they're probably about the right scale. So you'll have that as a kind of an extra guide to, in case you need more background on this topic or you're uncomfortable with that topic, go here to see more practice problems. Okay, so then let's take a look at the syllabus. Okay, fairly straightforward. We have the book that I just talked about here. There's some other ones. Some of these are available online, so if you do want to take a look at other books, feel free to look there. They can be handy. I do take some of the membrane filtration stuff from, I think, the second book here. No, it might be the third. From one of the other books. I'm going to post some of that content for you. So just be aware you don't have to look there, but you can, and you'd want to log into the LSU library for that. All right, objectives, we kind of already talked about all that. Grading will be fairly straightforward. That you'll see we have an exam, second exam, and the final exam. All those are counted equally. That's the plan right now. Homeworks also collectively will count for an exam. That should be, I'm pretty sure it'll just be 4, not approximately 5. Need to update that. And then participation will count as 1 further. So again, those will be the weekly quizzes. Just make sure you sign in to do that. I'll post those probably in the main section here as well. It'll say, participation quiz and give you the date and all that. Okay. And again, you'll get most of that credit just for completing it. I'm going to give you bonus points. I used to be able to assign for whoever participated got 5 points, but they changed the course feedback. You'll get them by completing the course feedback. So what I'm going to do, instead of assessing it individually, I'm going to say, okay, well, if 20% of you fill it out, then then everybody in the class gets 20% of 5 points. So you get 1 point. Usually it's more like 80%, so you'll probably get 4 points. So just to help encourage you, this will just be added as 5 on top of that 500. So that should help you understand how that would will work. Okay, homeworks. Hopefully I can make them fairly straightforward. If we have one due after Thanksgiving, and I'm trying to think how the timing will work, then I'm going to have you submit it online through Moodle. I might do that to give you the practice of submitting through that portal like I'll do with the final exam. But otherwise, I'll probably do it, let's see. I need to make a decision because I don't want to have to make you all come to class on the day that the homework is due. So I might change this to online. Usually I collect paper if possible. I'll make an announcement about that when we do homework number 1. But we talked a little bit about what they're going to be like. Usually the way I grade them is just simply, if you attempted it, you get half credit. If you got it right, full credit. And then we discuss them later. Maybe we can talk about it if I didn't structure it well. Usually works out all right. Exams I give partial credit for, so I take a lot closer of a look on your actual work. It's common to have most of the problem right, but you flip a negative or you forgot the conversion factor because you never have to deal with liters and cubic meters volumes, but you do now, and so you forget once, and I don't want to count that whole problem against you, so I give you most of the credit if it's just a mistake like that. All right. Exams 1 and 2 we're probably going to do here in person, so that's my expectation. I think that's going to be the easiest for the majority of you. If you do have some sort of issues with that, I'll certainly work with you. Might have to do a few in kind of a remote mode if some people are sick or whatever. All right. Talked about the participation stuff. So obviously we're using Moodle heavily. I think by now you can't get around that. Course schedule here is kind of an approximate deal. This is what I expect. I wouldn't be too surprised if class gets canceled on Thursday, so if that happens, we might bump some things back. Right now, as I have it, I've figured I would give you this Tuesday of Thanksgiving because we're not taking fall break. If we miss class Thursday, then might rethink that or just try to catch up so that we can still do that. I thought that would be a good arrangement. We'll see if the Hurricanes agree. Okay, so then once we come back, it'll just be basically one lecture that's delivered virtually, and then kind of a review session. I might do review sessions on Zoom, or if you guys are interested in that. But I'll have to think about that a little bit. 50 to 60 students, I just would rather avoid Zoom if I can. But we'll talk more about that as we get a little closer, see what you need. Okay, so then there's all this text in the back about kind of online plans. What you've already experienced now is basically it. So just if you have more questions or forget the link or something, you can find it down here. If you are uploading PDFs for me, I really do recommend using Office Lens. It's a very handy tool, available on smartphone devices, Apple as well as Android, and that'll let you scan your documents into one file, and it kind of manipulates them to look like a flat document more so than a weird, partly shaded and curved homework sheet or whatever that it might look like otherwise. Okay, so I'd appreciate that if you did that. Okay, any questions from you guys? I hope the audio is coming through well for the viewers online as well. I forgot to check and ask. I know some people commented, so I'm assuming so. Any questions, concerns? Yeah.
So you said that second textbook that you have online was good for what exactly?
They're good textbooks. I think some of them focus a little bit too much into the content for the level that I want to cover. So they might they might get a little more complicated than we need. However, the textbook that I'm assigning for our class really doesn't cover membrane filtration in particular. So I've sourced the membrane filtration stuff elsewhere, but hopefully I'll give a thorough enough PowerPoint and lecture information to get you what you need. But I will also, okay, thank you, Big Bert 35, commented on audio. So yeah, if you name yourself funny, you might get embarrassed when I read it out for the class, but I guess you're anonymous at that point. So if you do want to participate and have me know who you are, use something, you use your name or a part of your name so I can recognize you. And if you don't, that's fine. Up to you, as long as you're not doing something you should. Yeah, so the membrane filtration is kind of the one topic I'm gonna for sure go to another source. I'll give you a couple other resources here and there, case study. We'll probably talk about the Flint water crisis. I'll give you some outside resources on that as well. All right. How are you guys feeling about this semester? Can you guys feel like you can hear me pretty well? I think I wouldn't be as clear with another mask, so I went with this route. So hopefully they don't slap me on the wrist and tell me not to. All right, we have somebody says, with God on my side, the periodic table can't hurt me. That's what I keep telling myself. Excellent. All right. So anything else? Just feel free to let me know. They'll be available with email. Right now, I just put office hours as kind of contact me. If there's interest, and a lot of times it's typically before an exam, like at office hours, I can host a Zoom and let whoever wants to join in. And then there might be one or two people asking questions specifically. I'll ask whoever is asking for office hours if that's all right, and then I'll host it for the class for whoever wants to drop in. Happy to do a one-on-one if that's needed as well. Okay, format of exams. Got one last question I think you all might appreciate. Could you go over the format of the exams, how we can best be studying for them? Yeah, actually that's a good question. And what I'll do, I could actually pull up a prior exam for you. So just give me one moment. Usually what I do on the exams is I can't ask you exactly the same questions as as I gave you for homework or whatever, obviously. So what I will try to do is stretch you a little bit, but keep it within the scope of the skills you've learned. So I'm going to be teaching you about mass balances and such, and so I'm going to have you apply a mass balance to a system maybe slightly different than what we've done before. So in terms of studying, probably the best thing to do will be to look at what are the tools that you're using, and are you comfortable with those? So here's an example, I guess from fall of 2018. So we've got free response questions. So multiple part questions. They are kind of word problems. This is setting up the Mississippi as a sedimentation basin and asking you a few things about it. So A, B, and C, and then moving on to the next question. So they'll be a lot like your homework problems. You'll have homework problems that are essentially like this. Sometimes I interchange them. I'll use a past exam question for a homework question. So the homework should be a good avenue for you to get a feel for how well you're doing at it. And then the exam will should be something along those lines in terms of the tools and the difficulty. Sometimes I make a mistake. Last semester I made the second exam way too easy, and the students loved me. So that has happened. I've accidentally done the reverse and had to carve exams, so that can happen. I apologize if that happens. That's not my intent to be mean or anything. So that part that second question, that was just actually one single part, but relatively involved. Had to do a lot of calculations for that one problem. So yeah, typically 3 to 4 questions on a midterm, probably 5, maybe 6 questions on the final, and you get a little extra time on the final. Yeah. All right. Give it a moment or two longer for anybody watching online. Oh, actually, we have 24 viewers. That's cool. Yeah.
Can you post like practice exams before the exam, or?
I'm not going to be posting practice exams, so I spend a lot of time developing the problems, and I don't want them strewn about the internet everywhere. They kind of already are. So it takes a lot of effort for me to give you something that's new but the right scope. So the homework should and that book listings should be enough, I think.
Yeah.
And if you have a specific question, like I really am having a hard time with membranes and I don't have any other problems, I can certainly try to help with that and send another out to the class. And the membranes, actually, I will post a few problems as well to Moodle when we get there.
Okay.
All right. Well, thank you all. That'll be it for today. Next time we'll get into some course stuff.